students, in this video we are planning to discuss about the interference of light and Young's double slit experiment. So let us first of all study about the interference of light. As we have seen in the last video regarding the coherent and incoherent addition of waves, there is a redistribution of energy as a result of the superposition of two coherent waves. Remember that two independent sources of light are never going to be coherent. So now we will define first of all what is interference of light. The process of interference of light is the process of redistribution of energy. The process of redistribution of energy as a result of the coherent addition of waves. As a result of the superposition of coherent waves, that is what we will write. As a result of the superposition of coherent waves. The process of redistribution of energy as a result of the superposition of coherent waves. Now we have to see what is the definition or what is the conditions for sustained interference. Conditions of sustained interference. Conditions of sustained interference. The most important condition for sustained interference is sources must be coherent. Sources must be coherent. This is the most important condition of sustained interference. The second condition is sources must be monochromatic. Sources must be monochromatic. What is the meaning of monochromatic? Monochromatic means single wave. Then the third condition is again sources must be narrow. The sources must be narrow, that's the third condition for sustained interference. The fourth condition is sources must be of nearly same amplitude. The sources must be of nearly same amplitude to obtain a contrast between bright bands, that is maximum, and dark bands, which is minimum. Right, so these are the most important conditions of sustained interference. Now we are going to discuss about the Young's double slit experiment, a revolution to the wave theory of light, which is abbreviated as YDSE, Young's double slit experiment. Now, as I told in the previous video, as well as at the beginning of this video, that two independent sources of light never form coherent sources, right? Two independent sources of light never form coherent sources. Then, how can we obtain coherent sources? Okay, Thomas King was so brilliant enough to do that. What he has done is that he took an opaque material and made two narrow openings, because that is another condition of sustained interference, right? Narrow opening by name, and that openings are called by name slit. Slits, narrow opening is what is called slits. Then the light passing through the slit are allowed to fall on a screen kept at a very large distance. Let us take that distance as capital D. and the separation between the two slits. Let us choose this small d. The separation between the two slits is small d. Then a source of light is placed here. This is yes. Now this is S1. This is S2. Great. Now he allowed the light to incident from the source. So we are not using two different sources. It is the same source from which we derive two light sources, right? So here S1 and S2 act as two sources of light, but actually light S1 and S2 are got from the sources only, so we cannot say two independent. They are dependent because they are getting light from the same source, so they are not independent, two independent sources. But they serve the purpose of coherent sources. Now we have to set this point C. S1C and S2C. Now, C is the center of the screen. Let us take the path reference here. So, what will be the path reference here? S1. So, this is the path to which the first light travels. SS1 plus S1C minus. Path reference simply means the difference in path. SS2 plus S2C. Now here the source is placed symmetrically with respect to the slits. The source S1 and S2 are placed symmetrically with respect to slits. So I can say SS1 is equal to SS2 and S1C is also equal to S2C, which implies path reference is equal to 0 for the former case. There is no path reference here, man. Understand that there is no path reference in this case. No path reference. There is no path reference here, right? So, which means at the center of YDSC, will you get maximum or minimum? So, at the center, are you going to get a bright band or a dark band? So, what you see here at the center, path reference is equal to 0. Path reference is equal to 0 means the condition for maximum or the condition for the minimum. Tell me please. Is it the condition for maximum or is it the condition for minimum? Is the condition for maximum or is it the condition for minimum? It's a condition for, I have to say, maximum, right? So, in YDSC, I therefore say central band is a bright band. Central band is a bright band. So in YDSC, the central band is a bright band, I would say, right? Central band is a bright band in YDSC. Central band is a bright band in case of YDSC. Now we will consider another point in the path of light. Sorry. Yeah. Okay, yes. Now we'll consider this. S1, S2, C, M, N. So here I have to say path difference is equal to SS1 is already equal to SS2 as we said in the previous condition. Path difference is S2P minus S1P, right? Path difference is equal to S2P minus S1P. That's the path difference between the two superposing waves, right? Now what I'm going to do is that I'm going to apply. Let us take the triangle S1MP. And we'll apply Pythagoras theorem. Let me take this total distance. This total distance from the center is equal to xn. The distance of the nth band is what I mean here. So considering the triangle S1MP, we can see that taking the triangle S1MP, we can see that what? Pythagoras theorem. S1P square is equal to this distance. How much is this? D. D plus, what will be this distance going to be? MP square. MP square, D square plus MP square. That is D square plus MP is how much? This total is xn, this much is d by 2, right? D square plus xn minus d by 2, the whole square. That is S1P square. We will expand later. Now consider the triangle S2NP. Consider the triangle S2. Consider the triangle S2NP. What is it? S2NP. We can see that S2P square is equal to S2N, that is D, plus in the similar way you can write this much is again D by 2. So NP square, right? D square plus NP square, that is equal to D square plus X plus D by 2, the whole square. Now one important point you have to understand is that capital D is much greater than small d. Capital D is of the order of meter, whereas small d will be of the order of millimeter, and capital D is much greater than xn also. But we will now take the difference of this one. S2P square minus S1P square is equal to S2P square minus S1P square is equal to, when you take the difference of these two equations, you will get the answer as x plus d by 2 the whole square, right? I am taking the difference of this equation by this equation. D square minus d square is equal to minus xn minus, this is xn minus d by 2 the whole square, right? What is this comes out to be? Xn plus d by 2 the whole square minus xn minus d by 2 the whole square is, I am using the identity a plus b the whole square minus a minus b the whole square, that is equal to 4ab. Just learn it. So in place of this is 4 into, in place of a we have xn, in place of b we have d by 2, 4xn multiplied by d by 2, which is 2 into xn into d. 2xn d, right? S2P square minus S1P square is 2xn multiplied by d, right? But what is the left side square? This is S2P minus S1P into S2P plus S1P. That is equal to 2xn d. Okay, yes, now I'm just shifting it up. Oh, one more time here. So what I'm going to do is that from here I'm saying s2p minus s1p into, as I told you, these two terms, small d is a small quantity, xn is a small quantity. In sum, in the difference, what is what these terms are quite important, whereas in the sum we take S1p and S2p. So if you probably you might have been saying that, sir, you got S2p square, this term means can't you write this as approximately d square? Can't we write this also approximately d square? So that I am going to do. So in the sum of S2p and S1p, that is in this term, actually the contribution of this one is negligible. So I will take this as approximately 2p. What I am saying is, S2p is equal to root of d square plus xn plus d by 2 the whole square, which is approximately d, because where is it important? Where is the importance of these terms comes is in the difference of the quantities. So when you take the sum, we can neglect it. So that into d is equal to 2 into xn into capital small d. Okay, very mistake. Xn into small d, which gives path difference S2p minus S1p is approximately equal to, because I made an approximation here, xn into small d divided by capital D. Path difference S2p minus S1p is equal to xn into small d divided by capital D. So I will have an opportunity for you to look at these conditions properly once again. So look at this once more if you have any more confusions regarding this. Xn into small d divided by capital D, right? So this is the expression that we are getting for the path difference. Okay. Now I will take my attention to the next part. Path difference. Now what now I got is path difference is equal to xn into small d divided by capital D. So let us take the first condition. That is for constructive difference. Path difference required is n lambda, right? Where n is equal to 0, 1, 2, 3, etc. Order of the difference bands. That means xn into small d divided by capital D is equal to n lambda, or xn is equal to n into d lambda divided by small d. So we can define this as distance of the nth bright band. Distance of the nth bright band from the central branch. Distance of the nth bright band from the central band is given by this expression xn is equal to n into d lambda by small d. This is the distance of the nth bright band. Okay. Nth bright band or nth constructive reference band, I would say, where n can take the values 0, 1, 2, 3, etc. This is very, very important. The question is, what is the distance between constructive? Okay, that we will discuss later. So, second case. Condition for destructive reference, we got path difference is equal to 2n minus 1 lambda by 2. And be precise here, n is equal to 1, 2, 3, etc. In NCERT it is given as 2n plus 1, but I won't go for it because I am taking n is equal to n as 1, 2, 3. There the NCERT has taken n from 0, 1, 2, 3, etc. That may create confusions in problem. That's the reason I am going for this one. So xn into small d divided by capital D is equal to 2n minus 1 lambda by 2. Now I will get xn is equal to 2n minus 1 lambda capital D divided by 2 into small d. So let me tell you, this is the distance of the nth dark branch. Distance of the nth dark band from the center. Distance of the nth dark band from the center is xn is equal to 2n minus 1 lambda and capital D divided by 2 small d. Yes. Now we have to discuss about what is called fringe width. Fringe width or band width. So fringe width or band width is defined as it is the separation between consecutive bright bands or consecutive dark bands. So fringe width is defined as the separation between consecutive bright bands or consecutive dark bands. So we can write fringe width beta is equal to xn plus 1 minus xn. So I am taking for bright bands. So this is n plus 1 d lambda divided by small d, because you have seen condition for nth bright band is this one, n d lambda by small d. So as I take n plus 1 band, n plus 1 d lambda by small d minus n d lambda by small d, which can be proved as d lambda by small d. You can find the difference by yourself and you can see that fringe width beta is equal to d lambda divided by small d. Okay, what does that mean? Beta is equal to d lambda divided by small d means, the first point I can say is that beta is directly proportional to capital D. The fringe width beta is directly proportional to capital D. What is capital D? Distance between slit and screen. The distance between slit and screen is beta. The second thing I can say is that beta is inversely proportional to small d. What is small d? Distance between the two slits. And third one I can say is that beta is directly proportional to lambda. What is lambda? Wavelength of the light instant. So if I plot a graph between beta and capital D, the shape of the graph is a straight line. If I plot a graph between beta and small d, the shape of the graph is a rectangular hyperbola. So you have to understand this thing. Okay, so that's what is for today's video.